Hey, Algebra 2. I always have to move my face. So that's where we left off in part A. Let's go ahead and work on part B of the lesson. So here we have another example. They always do a standardized test practice. Not that we do a ton of standardized tests anymore, but the area of the rectangle shown is 72 square units. What is the value of x? So area is always length times width, so 3x times x plus 2. I'm going ahead and distribute that. 3x squared plus 6x equals 72. I think I can divide everything by 3. So if I factor that out and then divide both sides by 3, 3 goes into 7 twice. There's 1 left over. 24 equals, those are canceled, x squared plus 2x. 24 is still not a perfect square, so I do need to complete the square because that's the unit we're working on, equals 24. So I need to add something to make it a perfect square. And if I add it to the left side, I have to add it to the right side. That's going to be b over 2, quantity squared. b over 2 is 1, so 1 squared. That means I have x plus 1, quantity squared, equals 25. 25 is a nice number, isn't it? Because it's a perfect square. X plus 1, sorry, I hate, when I've taken college classes that have been online, I've always hated when my professor's pens mess up and they're like, oh, you can still read it, it's okay. Nope, I can't. So excuse me while I change that. I'm still solving this for x. I get x equals -1 plus or minus 5. Oops. Plus or minus 5, which I can simplify. I can do -1 plus 5, which is 4, and -1 minus 5, which is -6. 4 and -6 is right here. So those are the area of the rectangle shown. What is the value of x? That actually cannot be right because you cannot have a negative value for x. So your answer is only B. Let's just double check. Yep, we reject x equals 6. It gets thrown out. It's not valid. We don't want it. It's got to go. All right. Extra page just in case. Ooh, another extra page just in case. All right, so we're going to solve these by completing the square. I'm going to do a bit for you. This is a perfect square, but if you look, that's x times x, that's 2 times 2. 2 times 2 times x is not equal to 6, so that doesn't work. So we need to find the perfect square to make that work. I'm going to change to a black pen. So first, I'm going to isolate this part and do plus a box equals -4, subtract 4 from both sides, plus a box. 6 over 2 is 3 squared. 3 squared is 9. So that gives me a perfect square trinomial. X plus 3 quantity squared equals 5. Square root of both sides. I'm going to move up here. I get x plus 3 equals plus or minus root 5. Subtract 3 from both sides. And for that one, I'm done. Okay? I'm going to give you the answer to number 8 as soon as I find it. This one's going to be 5 plus or minus root 17. And then we're going to do number 9 because there's an a term here. We're going to practice that one just a little bit more. So let's go ahead and factor out that 2. N squared minus 2n minus 7 equals 0. And then divide both sides by 2, which cancels it out. So if I divide both sides by 2, The 2 is gone. Then I'm left with n squared minus 2n minus 7 equals 0. And that's much easier to do. Okay, so let's subtract 7. No. Let's add 7 to both sides. And I have n squared minus 2n plus what we need to figure out equals 7 plus what we need to figure out. B, negative 2, negative 2 over 2 squared is negative 1 squared. And that's where we are. So that gives me a perfect square trinomial, and I get n minus 1 quantity squared. Sorry, I should put a negative there in parentheses. That makes better sense. Equals 8. Square root of both sides. I have n minus 1 equals plus or minus root 8. See if I have a little more paper here. Add 1 to both sides. I have n equals 1 plus or minus root 8. Pause. Are we done? No, we're not. Root 8 is not in its simplest form, and I need you guys to recognize that. I'm going to keep on working on this next page here. I have root 8 is 4 times 2, where 4 is a perfect square. I have 1 plus or minus 2 root 2, and that is my final answer. Okay, everything always needs to be in its simplest form. All right, let's see. Number 10 is another A. I can divide everything by 3. Oops. I click a button on my little pen. 3, 6 equals 0. So go ahead and take it from there. I'll give you the answer. It is negative 2 plus or minus root 10. Here, a little bit messier. If I were sitting in your seat, I would say, what, Miss Carly, I don't know what to do there. I have 6x squared. I'm going to distribute. Plus 6 times 8 is 48 equals 12. Now I'm going to divide, well, I'll factor out the 6. I guess I could have just distributed 7. And divide both sides by 6. I'm trying to simplify my work. I have x squared plus 8x equals 2. Now I need to figure out what goes in the box for the perfect square trinomial. I'm going to let you finish that because you have the skills to do it. And my answer is going to be negative 4 plus or minus 3 root 2. Okay? Let's get a little smarter with this one and divide. I have p times p minus 2 equals 25. P squared minus 2p equals 25. So I really need to put something in the box, okay? And that's going to give me an answer. You guys can take it from here. 1 plus or minus root 26. You guys got it. I believe in you. All right, let's see. We have 2 more examples, 6 and 7. Let's talk vertex form. Vertex form, I've told you, is really, really important as your math gets harder. We use it in pre-calculus and calculus all the time. So it's really important for you to be able to put something into vertex form. Let's read. Recall that the vertex form of quadratic function is y equals a times the quantity x minus h squared plus k, where h and k is the vertex of the function's graph. To write a quadratic function in vertex form, we can actually use completing the square if something isn't a perfect square. So here we have an example, and we're going to write it in vertex form. y equals x squared minus 10x plus 22. Okay, 22 is not a perfect square trinomial. Okay, so I need to figure out what goes in the box. And what goes in the box, because I need a perfect square trinomial. I just can't, this isn't set equal to 0, so I can't really do that whole like move the c term, set it equal to 0, whatever. But I can put what's in the box. I have negative 10 over 2 quantity squared. Negative 10 over 2 is negative 5, so really I need a negative 5 squared. And if I add negative 5 squared there, I add negative 5 squared is 25 there. Okay, does that make sense? All I've done is if I add something to one side of the equal sign, I have to add it to the other. So I have y plus 25 equals, I have a perfect square trinomial. I almost have vertex form. I just need to move this. Oops, there we go. Those are gone. My vertex form is x minus 5 squared minus 3. So my vertex is x minus h, positive 5, plus k, negative 3 is my vertex. And that's the whole point. So I could actually plot it pretty well. If I go over 5, down 3, I have a happy parabola. Really bad drawing. Don't do that on your own. All right, example 7. Find the maximum value of a quadratic function. So the height, y, and feet of a baseball t seconds after it is hit is given by the function. You know baseball's going to get hit, and it's going to go in, rah! So we're going to have like a negative equation because it's an unhappy parabola, right? And we do. So it's given by this function. Find the maximum height of the baseball. We can figure it out. I could put it in Desmos and graph it, or I can put it in vertex form and figure it out a lot better. So let's go ahead and do y plus a box equals negative 16 t squared. So I'm going to take a 16 out here. 96 divided by 16. I should know this one. 6. So I took out a negative 16, so I have minus 6t plus a box plus 3. So what goes in that box is negative 6 over 2, so b over 2 quantity squared. So that's a negative 3 squared. Negative 3 squared is 9. So I have y plus 9 equals negative 16, and that's a perfect square trinomial now. So I get t minus 3 quantity squared plus 3. And I can subtract 9 from both sides. My final equation is y equals negative 16, t minus 3 squared minus 6. So my vertex is x minus h plus k. Let's look. I believe I may have done something wrong. I did. All right. We're gonna just own this error. I think I need to start there. Because I have an a term, I completely forgot that I need to keep that into account. I cannot just add the c to both sides. So here I did a plus negative 3 squared, which is 9. Over here I need to actually have negative 16, that's not a 16, times 9. in that box. So it's really y minus 144 equals negative 16, perfect square trinomial, t minus 3 squared plus 3. Add 144 to both sides. I have negative 16 t minus 3 squared plus 147. So my vertex is actually x minus h, 3, comma, plus k. So the maximum is just the 147. 147 feet is the maximum. Okay. Tricky, huh? All right, vertex form. See how I always do the same thing? All right, the box is negative 8 over 2 squared. So we're going to put negative 4 squared. Negative 4 squared is 16. Here I have a perfect square trinomial, x minus 4 squared. Subtract 16 from both sides. The vertex is x minus h, so it's 4 plus k. Oops. That is the vertex. Let's double check. 13, 4, 1. Good job. Okay, I'm going to give you the answer to this one. And the vertex is negative 3, comma, negative 6. Okay, another one without the a term. So we have y equals x minus 2 quantity squared minus 8, and the vertex is x minus h, so 2, negative 8. Okay. Same type of problem here. It would work out to be y equals x minus something squared plus 102, because the maximum is 102 feet. Okay, this is okay. It's irrelevant. It's still going to get us to the answer, but we're good. I don't want to take up too much more of your video time. All right, that's it. That is lesson 1.7. We're going to do 1.8 next. Good job.